We're in 6.2, solving inequalities with multiplication and division. So if we're going to show the multiplication property of inequality, what are we going to do to both sides? Multiply. We're going to multiply. It's the multiplication property. So we're going to multiply. Okay? So if A is less than B and C is greater than 0, which means this factor is positive, then who can give me the rule? Since we are going to be multiplying both sides. Sophia. Good. AC then is less than BC. The sign doesn't change, does it? Inequalities are a little tedious because we have to show that the same is true for a greater than inequality. So if A is greater than B and C is a positive value, then if we multiply both sides by AC, does that change the sign? Does it? No. The sign doesn't change. So, what do you think is coming next? Well, no, we're still in the multiplication property. If A is less than B and we have a factor that is negative rather than positive, and we multiply both sides of the inequality by this factor, what does that do to the inequality? Do you remember when we multiply both sides of an inequality by a negative, it changes the sign. We switch the sign.
Oh.
Okay? And the same is true if we start with a greater than inequality. No matter the inequality, if we multiply both sides by a negative, then if A was greater than B, now AC is less than BC because we have multiplied both sides by a negative. Well, actually, just give me a number, any number.
10.
10 is, give me another number.
5.
5. How is 10 related to 5, Nico?
10 is greater than 5.
Does everyone agree? 10 is greater than 5? Okay. So if we were to take this, let's do it twice. If we were to take this and now we're showing the multiplication property, again, you know, if we do this, if we use the same operation on both sides, we should have a true statement still, right? Since we're beginning with a true statement here, 10 is greater than 5, give me some number that we could multiply to both sides of it.
6.
Okay, so if we multiply both sides of this by 6, this is a positive number, right? So when we simplify, 6 times 10 is?
60.
60, and 5 times 6 is 30. So 60 is still greater than, the left side is still greater than the right side, right? Does everyone see that? Let's try it now with changing those to negatives. So if we're going to multiply both sides by 6, but we call it negative 6 now, we multiply by a negative. What is negative 6 times 10? Negative 60. This side is negative 30. Which of these numbers really is greater? Do you see how we have to switch the sign? See this? These signs are now different because we have multiplied both sides by a negative. And again, it has everything to do with the absolute distance from 0, right? The number became greater, absolute value. 60 is greater than 10, but it is negative 60, so it's further away from 0 than negative 30. It's to the left. Okay, so that's why we have to switch signs when multiplying both sides by a negative. So let's try. Let's solve and graph using our multiplication property. Okay, so we're going to solve and graph. Okay, so Sabrina used the factor 9 on both sides. She multiplied both sides by 9. Does that cause a sign change? No, because it was a positive factor, it doesn't. Okay? And she has a number line with at least 2 numbers on it. And y's are greater than 27, so it's pointing to the right. Good job. Okay, let's try another one. How about if m over -2 is greater than 5? Okay, so Jimena multiplied both sides by -2, which caused the inequality sign to change directions. And then she has an open dot and an arrow to the left. Okay? So the division property of inequality is similar, isn't it? But when we're using the division property of inequality, what operation are we using?
Multiplication.
We're using division to undo multiplication.
What?
That's why you're saying that. If we see multiplication operating right there next to our variable, then we'll use division. That's what you're saying, but this is going to show us using division. Okay? So if a is less than b and we are dividing both sides by a positive number, then who can finish the rule? Sophia. Good. A over C is less than B over C. And the C's should be shifted over a little bit. Okay, and then a similar statement can be made for a greater than, right? If A is greater than B and we have C remaining positive still. Ryan, can you finish the rule? It's still greater than. Good. We don't have a sign change because when I say sign change, I'm talking about the inequality sign. It does not change because we have just divided both sides by a positive. Okay? So this is the tricky part. If A is less than B and C is now negative, then when we divide both sides, what happens now? Isabella, A over C is, it was less than, A was less than B, so now A over C will be, good, good, we have a sign change. Dividing by a negative changes your inequality sign. And the final statement, just like the last one, but instead we're starting with a greater than, right? A is greater than B. So when we divide both sides by a negative, can you finish the statement, please? Bailey. A over C would be now this one started with A being greater than B. So when you divide by a negative, very good, the sign has changed to a less than sign. Okay? So, solve and graph. Solve means isolate the variable. And how do we do that here, Braden? Divide both sides by -4. Good. And what I recommend right now is the second you divide both sides by a negative, go do what? Change your sign. Do it right now before you forget. People get all involved with the computation, figuring out your division and stuff, and then you forget about the fact that you divided by a negative. If you write it down first thing and get in that habit, hopefully you won't forget. Okay? So now we have on the left X, and on the right we have anyone?
-9.
-9. Okay. And we have -9. And what is just greater than -9?
-8.
Very good. And we can put a couple numbers on. Is this going to be an open or closed dot? Because there is no equal sign under there, it's open. And X's are all greater than -9, so which direction? I see you pointing to the right. Good. 3x is less than 18. Yes? All for x.
Divide by 3.
Okay. And then you ask yourself, does that change the sign? That's right, it doesn't. So go put the sign down that remained a less than sign. Okay? We read it left to right, and the less than is what we cross first. So we say that. And what do we have then? X is less than what? Good. So on the number line, we want to see 6. And so what type of a dot there, Alana? Good, because there's no equal sign under there. And which direction? Good, to the left. And you can test it. 5 is to the left. And is 5 less than 6? Yes, so you can test it with any point that falls on your line, on your ray. Okay, let's try this with a real world problem. We're going to change this into a math inequality statement. You have a budget of $45 to buy pizza for a meeting. Pizzas cost $7.50 each. Write and solve an inequality to find the number of pizzas you can buy. Okay.
7.5x.
So, how'd you get that, 7.5x?
Because pizza costs 7 like x is how many pizzas.
$7.50 each. There's a rate. There's a rate. We multiply rates by whatever was in the denominator. And so it's $7.50 per pizza. So we're multiplying by numbers of pizzas. Very good. So 750x. What else do you want to say?
And then less than or equal to 45.
Less than or equal to 45. Does this make sense? Does this make sense? Raise your hand if you think it makes sense. Good. You could just start with 750 times x, and then you know that the upper limit is 45, and then you can think about what inequality sign needs to go there. May a person spend more than 45? No, so this whole side can't be greater than that whole side, and so on. He has stated it beautifully here. So it's a simple inequality, really. But there's another piece we could add to this, actually. We haven't talked about this yet. Can anybody think of something that might be true here? Well, let's solve this and graph it, and then maybe you'll see it. So how do we solve this, Nick?
Well, you can just put line at 7.5, 7 here, 8, and then, well, I have to say how.
What do you?
I thought we were just graphing. Divide by 7.5.
Good. He knows what we need to do. He knows. X is less. Hey, did that change our sign, that division? No. Okay, so how many 750s go into 45? Do you know?
6 apparently.
What is 750 times 2? 15, right? And then 15 times 3,
It's
so 2 times
6.
So very good, 6. So when you do this, we don't even need to see 750, do we, on this number line? We need to see 6.
Yes, so that would be a circle on 6,
You could get 6.
and then going left.
We need to show some other numbers here. How about 3, 0, negative 3? So does this make sense? Does anybody have an issue with any of this? What is the problem, Emily?
Well, because you can't buy negative 3 pizzas.
You can't?
So, no.
Are you sure?
Yes.
Okay, so you can't buy negative 3 pizzas. Did you know that? So there's a limit to this on the bottom side here. What's the smallest number you could buy? 0. So because there's a smallest spot, we really have to stop here, don't we? You can go anywhere from 0 to 6 pizzas. So how could we change the inequality to reflect that? What's the bottom number that you could get? 0. We could put it on the left here. And may x's be greater than 0?
Oh, yeah.
Yes. And may x's equal 0?
Yes.
So you could say that. Okay, that's a little more advanced. It's a 3-part inequality. Okay? Okay, there you go.
What is